Good morning, everyone. I am delighted to welcome you all today. Today, we will be exploring the important topic of User Needs Specifications, or UNS. Our focus will be on ensuring clarity, compliance, and creating a system design that is truly fit for purpose. I am Dr. S.K. Singh, and I look forward to guiding you through this presentation. We'll briefly cover key concepts, best practices, and how to effectively develop and implement UNS. So let's get started. Let's start by looking at what this slide is really about. It's all centered around understanding what a user needs from a system or equipment. Essentially, we want to clearly define those requirements to make sure everyone is on the same page. This clarity is crucial because it helps prevent misunderstandings between the user and the vendor, ensuring that the system meets the intended purpose. Next, we see that defining these needs also supports important aspects like quality, safety, and lifecycle management. When we know exactly what we need, it's easier to maintain high-quality standards, ensure safety protocols are followed, and manage the system throughout its entire lifecycle. Another key point here is that these definitions form the foundation for various validation activities, specifically design qualification, installation qualification, operational qualification, and performance qualification. These are all critical steps in making sure the system performs as intended and remains compliant over time. Finally, this slide introduces the concept of UNS, which stands for User Needs Specification. It's a vital document that captures all these requirements clearly and thoroughly, serving as a baseline for the entire validation process and for managing changes effectively. Overall, this slide emphasizes the importance of clarity and thorough documentation in ensuring systems are effective, safe, and compliant throughout their life cycle. Let's talk about why providing clear expectations to vendors is so crucial. When we set clear guidelines, it helps avoid any ambiguity in design and commissioning processes. This clarity ensures everyone is on the same page, which ultimately reduces misunderstandings and errors. It's also essential to emphasize regulatory compliance. We need to meet standards like EU GMP, WHO, US FDA, and GAMP5. These regulations are the backbone of quality and safety in our industry, so adhering to them is critical for success. Supporting quality, safety, performance, and lifecycle management is another key reason why this approach is so important. It creates a solid foundation that guides us through every stage, from initial design to ongoing maintenance. This baseline is fundamental for several critical activities, including design qualification, installation qualification, operational qualification, performance qualification, and system change control. Having a clear baseline helps us verify and validate each step effectively, ensuring everything functions as intended. Now, why is UNS, our unique standard, so vital in this context? Because it ensures consistency, compliance, and quality across all our projects. It forms the backbone of our quality assurance efforts, making sure we meet all regulatory and internal standards seamlessly. Let's start by talking about the importance of defining the intended purpose and boundaries of our system. This step helps us clarify what exactly we're working with and sets clear expectations from the beginning. First, we need to specify the type of system or equipment we're dealing with, whether it's a manufacturing line, a quality control lab setup, a warehouse automation system, utilities, or even software solutions. Understanding the specific type helps tailor our approach. Next, we should identify the application area. Is this system used in manufacturing, QC labs, warehouses, utilities, or perhaps software? Pinpointing the application area ensures we're aligning our design and requirements with the actual environment and operational needs. Then, we move on to defining the functional and operational requirements. What should this system do? How should it operate day to day? Clarifying these points helps us develop a solution that meets actual operational needs. We also need to consider regulatory and safety requirements. Every industry has standards and safety protocols that our system must comply with. Ensuring this compliance is critical for legal, safety, and quality reasons. Another key point is the integration and interface needs. How will this system connect with other systems or equipment? Defining interface requirements early on helps facilitate smooth integration and avoids future compatibility issues. Finally, we must establish the scope of the uninterruptible system, or UNS. Knowing what is included and what isn't helps set boundaries and focus our efforts effectively. Overall, clearly defining these aspects creates a solid foundation for the entire project, ensuring everyone is aligned and that we address all critical factors from the start. Let's walk through the UNS development process. First, we start with user needs identification. This is where we gather and understand what the end users actually require from the system or product. It's crucial because it sets the foundation for everything that follows. Next, we incorporate cross-functional inputs, involving teams like QA, engineering, IT, production, and quality control. Their diverse perspectives help ensure we cover all angles and potential issues early on. Then, we move on to drafting UNS requirements. Here, we translate those needs and inputs into clear, detailed requirements that will guide the development process. After that, a risk-based assessment is conducted. This step helps us identify and evaluate potential risks, so we can address them proactively and ensure safety and compliance. Once the assessment is complete, we proceed to review and approval. This is where stakeholders verify that the requirements meet the needs and standards before moving forward. Finally, we have vendor communication and finalization, where we coordinate with vendors to finalize specifications and ensure everyone is aligned. This entire process is designed to create a thorough, collaborative, and risk-aware development cycle, which ultimately supports the overall quality and safety of our projects. Let's start by discussing data integrity, specifically the ALCOA+ principles, which are fundamental to maintaining trust in our data. ALCOA+ emphasizes that data must be attributable, legible, contemporaneous, original, and accurate, with additional requirements for complete, consistent, enduring, and available data. Ensuring data integrity is critical across all aspects of our operations. Moving on to regulatory and GMP needs, it's essential that our systems and processes align with the strict standards set by regulators and good manufacturing practices. This ensures that our products are safe, effective, and of high quality, and that we remain compliant at all times. Integration needs are also vital. Our systems must seamlessly communicate with each other, enabling smooth data flow and process automation. This reduces errors and improves efficiency, which is crucial in a highly regulated environment. Documentation plays a key role too. Proper documentation provides a clear record of all activities, decisions, and changes throughout the product lifecycle. It's not just about compliance, but also about having a reliable audit trail. Speaking of the lifecycle, our systems need to support all phases, from development through manufacturing, quality control, and eventual decommissioning. Lifecycle requirements ensure that the system remains compliant, functional, and secure throughout its entire lifespan. Next, let's look at the system overview. We need a clear understanding of the architecture, components, and how everything fits together to support our functional and performance needs. Functional requirements describe what the system must do to meet user needs, things like data processing, reporting, and user access. Performance requirements focus on how well the system performs under load, its speed, reliability, and availability. Technical and design needs are about the underlying technology and architecture. They must be robust, scalable, and secure to support current and future requirements. Safety requirements are non-negotiable, especially when systems impact patient safety or product quality. We must design with safety in mind at every stage. Environmental and utility needs refer to the infrastructure supporting the system: power, HVAC, cleanroom conditions, and other utilities that ensure optimal operation and compliance with environmental standards. Finally, let's talk about the key components of a unique system number, or UNS. This is essential for traceability, ensuring every system or piece of equipment can be uniquely identified throughout its life cycle, simplifying audits and maintenance. Bringing it all together, these points form the backbone of a compliant, reliable, and efficient system that supports our overall mission to deliver high-quality, safe products. Let's now look at some of the key performance parameters we need to consider. First, temperature range, accuracy, and repeatability are crucial because they directly impact the quality and consistency of our process. Maintaining precise temperature control ensures reliable results over time. Next, we have production capacity, which tells us how much we can produce in a given timeframe. Understanding cycle time is also essential. It's the duration of each process cycle, influencing overall throughput. Tolerances are another vital aspect. They define the acceptable limits within which our measurements or parts must fall. This includes parameters like pressure, flow, relative humidity, speed, and throughput. Monitoring these ensures we stay within specifications and avoid defects. Uptime and availability targets are about maximizing operational time and minimizing downtime. The more reliable our equipment, the better we can meet demand without interruptions. Finally, all these factors tie into our overall performance requirements. They set the standards we need to meet to ensure efficiency, quality, and reliability throughout the production process. Keeping these key points in mind helps us align our equipment and processes with our broader operational goals. Now, let's delve into some key compliance frameworks and standards that are essential in our industry. First, we have GMP and CGMP, which stand for Good Manufacturing Practice and Current Good Manufacturing Practice. These are fundamental to ensuring product quality and patient safety by setting strict guidelines for manufacturing processes. Next, there's GAMP5, which focuses on the system development lifecycle. It provides a risk-based approach to developing and maintaining automated systems, helping us ensure that our systems are reliable and compliant throughout their lifespan. We also need to be aware of 21 CFR Part 11 compliance, which governs electronic records and signatures. This regulation is critical for maintaining the integrity and authenticity of digital data in our systems. On the European side, Annex 11 of EU GMP regulations aligns with these principles, emphasizing the importance of electronic records and data integrity within the EU market. Speaking of data integrity, I want to highlight the concept of ALCOA+, which stands for attributable, legible, contemporaneous, original, accurate, plus complete, consistent, and enduring. This framework is central to maintaining trustworthy data, which is vital for audits and inspections. Additionally, we must consider overall compliance requirements, which encompass these standards and regulations, ensuring that every aspect of our operations aligns with industry expectations and legal mandates. By integrating these principles, GMP, GAMP5, 21 CFR Part 11, Annex 11, ALCOA+, and risk management, we create a robust foundation for quality, data integrity, and regulatory compliance across our processes. Let's now look at some essential components for maintaining security and integrity in our data management. First, secure user access controls are fundamental. They ensure that only authorized individuals can access sensitive information, which helps prevent unauthorized data breaches. Next, electronic signatures and audit trails play a crucial role. Electronic signatures verify the authenticity of documents, while audit trails provide a detailed record of all actions taken, creating accountability and transparency. Data backup and archival are equally important. Regular backups protect us from data loss, and archiving ensures historical data is preserved securely for future reference or compliance needs. Metadata retention refers to keeping descriptive information about our data, like creation date, author, or version, which is vital for managing and retrieving data efficiently over time. Access rights, whether for admins, users, or guests, help us define who can do what within our systems. Clear role definitions prevent misuse and ensure proper control over data and system functionalities. Traceability and version control are essential for tracking changes over time. They let us see who made modifications and when, which is key for maintaining data accuracy and accountability. Finally, data integrity requirements encompass all these points, ensuring that our data remains accurate, consistent, and trustworthy throughout its life cycle. All these elements connect to our overall goal, safeguarding data while maintaining usability and compliance. They form the backbone of a robust data management strategy. Let's take a moment to talk about electrical and mechanical safety standards. It's essential to ensure that all equipment operates within safe limits to prevent accidents and damage. That's why establishing clear, safe operating limits is so important. They set the boundaries for normal operation, helping us avoid risks. Next, we need to consider required interlocks. These are safety mechanisms that prevent the system from running under unsafe conditions. They act like safety gates, only allowing operation when everything is in the right state. Emergency stops are another critical aspect. These are easily accessible controls that allow operators to shut down equipment immediately in case of an emergency, minimizing potential harm. Moving on, for cleanroom environments, compatibility with ISO classes is vital. This ensures that the equipment doesn't compromise the strict cleanliness standards of the cleanroom, maintaining product integrity and safety. We also need to consider the utilities required: power, compressed air, HVAC conditions. Knowing the exact utilities needed helps us plan properly and ensures the environment supports the equipment's optimal performance. Finally, safety and environmental requirements encompass not just protecting people, but also minimizing environmental impact. Complying with these standards is crucial for safe, responsible operation and aligns with our overall goal of sustainable, safe practices. Now, let's talk about vendor deliverables. These are the key documents and items that vendors are expected to provide throughout the project. First, we have design documents, which outline the specifications and plans for the equipment or systems. These are crucial because they form the basis for everything that follows. Next are FAT and SAT protocols, factory and site acceptance testing protocols. These ensure that the equipment meets the required standards before it's fully accepted. Calibration certificates are also essential because they verify that instruments and devices are properly calibrated and accurate. Lastly, training and manuals are provided to ensure your team can operate and maintain the equipment effectively. Moving on to verification, this is a critical part of the process. It starts with UNS, which refers to User Requirement Specification, then moves through DQ, or Design Qualification, followed by FAT and SAT, and finally IQ, OQ, and PQ, Installation, Operational, and Performance Qualifications. Each step ensures that the system is built and operates according to the original requirements. To keep everything transparent and traceable, we use a traceability matrix. This matrix links all the testing activities back to the original URS points, making sure that every requirement is tested and verified properly. In summary, these vendor deliverables and verification steps help us maintain quality, ensure compliance, and ultimately deliver a system that meets all your needs. URS, or User Requirement Specification, serves as the foundational document for many critical phases in our project. It's essentially the baseline that guides us through DQ verification, ensuring that the design and development meet the initial needs. It also provides the reference point for FAT and SAT alignment, helping us confirm that the system functions correctly before and after installation. When we move into IQ, OQ, and PQ qualification, the URS remains our touchstone, making sure that each stage aligns with the original requirements. Another key aspect is the traceability matrix, which links the URS directly to our test cases. This ensures that every requirement is accounted for and tested thoroughly. Finally, the URS helps define acceptance criteria and verification standards, giving us clear benchmarks to determine whether the system is ready for validation and ultimately for use. Overall, this slide emphasizes how the URS acts as the backbone throughout the entire project lifecycle, connecting the initial needs to the detailed testing and validation processes. It's crucial because it keeps everything aligned and transparent, ensuring we meet our quality and compliance goals. UNS, or Unified Nomming System, really serves as the foundation for successful system design, procurement, and validation. It helps ensure that everyone involved is on the same page, using consistent terminology and specifications throughout the process. This consistency is crucial for avoiding misunderstandings and errors. When we have a strong UNS in place, it naturally promotes compliance with standards and quality requirements, which are vital for the integrity of the system. It also enhances operational efficiency, because teams can work more smoothly when they're aligned. A robust UNS doesn't just support immediate project needs, it also reduces lifecycle costs by preventing costly rework or adjustments down the line. Plus, it helps us maintain long-term system performance, ensuring reliability and longevity. So, in summary, a well-implemented UNS underpins every stage of the system's life cycle and ultimately leads to better, more efficient, and cost-effective outcomes. This ties back to our overall theme of building smarter, more sustainable systems from the ground up. For further support, please don't hesitate to reach out to us. We're here to help with any questions or additional information you might need. Feel free to contact us through the provided details. Thank you very much for your time and attention today. We appreciate your interest and look forward to staying connected.